Alright, these are our notes for section 5.7 on rational exponents. And we learned what rational means, rational numbers are, and it means that rational numbers are fractions. So today we're going to look at numbers, expressions that have exponents that are fractions, and we're going to learn how to solve them. Now the big idea today is that you can take those rational exponents, and they can be rewritten as radicals, which is something we're familiar with. That's primarily what this chapter focuses on. Square roots, cube roots, fifth roots, tenth roots, all of that stuff. So if we have a rational exponent, we can take it and rewrite it as a radical, which is something we're more familiar with. Now there's two big ideas, key ideas that you're going to use today. And the first one is that if we have b, some number, some variable, to a fraction exponent, or rational exponent, we can rewrite it. Notice that we have b to the 1 over n, and that's going to become the nth root of b to the first. Okay, so what happens here is that our numerator becomes the exponent, and our denominator becomes the index. Okay, let's look at that again. We have b to the 1 over n power. The 1 went with the b and became the exponent underneath our radical sign, part of our radicand. So it became the exponent on our radicand. And then the n, the denominator, became the index out in front of the radical. Okay, the little number we write up there. I've got an example here, a to the 1/3. If we're using this idea, it's going to become, the numerator goes with the base. Okay, so our 1 goes with the a, and then our denominator becomes the index on the root. So we have the cube root, the third root, of a to the first. And that's all we have to do. It's the big idea for today. Now, they're all not going to have numerators of 1, so that's what the second one is. b to the m over n, that's going to become, we're going to use the same idea, the nth root, because that's what our denominator is, of b to the m power. Okay, now there is another way to write that. So it could also be the nth root of b in parentheses to the m power. Those are equal. You get the same thing either way. Primarily, we're going to use this one here. Okay, it's going to be underneath. The exponent's going to go on that base, but you could rewrite it so that the exponent is for the whole thing. Okay, everything is taken to the m power. Now, one thing you do have to remember is that this one, especially this last one here, does not work if b is less than 0, which means it would be negative, okay? And at the same time, n is even. Okay, both of these have to happen at the same time. b is less than 0, which means it's negative, and n is even. If that happens, okay, we would have something like, let's look at a problem here. Let's say we have negative 4 to the 1/2 power. Okay, if we're going to work that out, it would become, if we were going to rewrite it, the square root of negative 4 to the first, and I'm going to rewrite it again so it looks a little nicer, square root of negative 4, which we've already learned has no real answer, okay, no real roots, because there is no number that we could take to the second power that we could square to give us a negative 4. So that's what this means, that if b is less than 0 or negative and n is even, if they happen at the same time, you can't do that. It's not going to work. So it's just something to watch out for, okay? Got 4 examples, sorry, and the first thing we're going to look at is rewriting these rational exponents in radical form. I'm going to give you a exponent that's a fraction, and you have to change it so that it's a radical. First one here is b to the 1/5. We're going to use that same rule we've been using, okay? The denominator becomes the index, and the numerator becomes the exponent. So there's our answer, the 5th root of b to the first. The next one, x to the 1/2. That's going to become, let's write it down here, index is the denominator, and the exponent is the numerator. So the square root of x to the first, we don't have to write that 2 though, so it's really going to become square root of x. It's the same thing, just rewritten a little nicer. Now the next one is a little different. This one here, y to the 1/7 times y to the 4/7. I want you to think back to the first part of chapter 5. When we have two bases that are the same in the exponents, what do we do with those exponents? If we're multiplying them together, we add them. Okay, so we really have 1/7 plus 4/7. And our denominators are the same, so that's nice. When we add fractions, we add across. 1 plus 4 is 5, and the denominator stays the same. So this is really y to the 5/7. And we want to rewrite that, so it's going to become the 7th root of y to the 5th. Or we could say the 7th root of y in parentheses to the 5th. Both of those are acceptable. We're going to focus on using that top one though. Okay, I just want you to see that both are acceptable ways to write it. We do have one more here, x to the negative 2/3 power. We're going to talk about this because this one's kind of tricky. Okay. First thing we have to notice is that we have a negative exponent. Now remember back to when we started talking about monomials, when we have a negative exponent, it has to move to the bottom. Okay, it has to become part of the denominator in order to make that exponent positive. So now we have 1 over x to the 2/3 power. Let's rewrite that. So now it's 1 over the cube root of x squared. There is something wrong with this though. It breaks one of our rules that we can't have a radical in the denominator of a fraction. Okay, so we're going to have to go through and rationalize that denominator, which means we're going to have to multiply by a well-chosen 1. To figure out what that well-chosen 1 is, we're going to look at that index. Okay, our index is a 3, and we need to have a group of 3 things that are the same in order to get rid of that radical in the bottom. Well, we have two x's. X squared is really x times x. So to get our group of 3, we need to have one more. So we're going to multiply by the cube root of x to the first, because we just need 1. When we multiply fractions, we multiply straight across. 1 times the cube root of x is going to be cube root of x over the cube root of x squared times the cube root of x is going to be the cube root of x cubed, because we add those exponents. But the exponent in the index and the radical sign, they cancel each other out. So we end up getting the cube root of x over the bottom, which is just x now. And we've gotten rid of our radical in the denominator. So we've rationalized it, and that's what we want. So I want you to notice here, if you've got a negative exponent, it's going to take you a couple extra steps, because more than likely you're going to have to rationalize that denominator in order to get rid of it. Okay, get rid of the denominator in the fraction. Because we can rewrite rational exponents as radicals. It's the same thing. They go together. So whenever you see a rational exponent in the denominator, you need to think of it as a radical in the denominator. Okay, you got to rationalize it. And those are our examples for rewriting rational exponents in radical form. Now the second set, we're going to work backward. We're going to rewrite these. They're already in radical form. We're going to rewrite them as rational exponents. So we're going to go the opposite direction. First one here, we have the 7th root of b to the 4th. We're going to look at what's underneath there, the b, and the exponent became our numerator, and then the index became our denominator. And that's all we need to do. There's our answer, b to the 4/7. Okay? Let's look at the next one here. The next one's written a little differently. Okay, we have the quantity, the cube root of w to the 2nd power. We treat it the same way though. Okay? This is going to be our base, the w. The index is going to be our denominator, so we know it's going to be a 3 on the bottom. And then this outside exponent works just like the inside one over here. They're the same idea, just both are written differently. So it becomes our numerator. And there's our answer, w to the 2/3. This third one's kind of tricky. This is one that causes a lot of people problems, okay? Because there's more than one thing underneath the radical. One way to do this is to split them up. You can pull them apart and make it the cube root of 6 times the cube root of x to the 5th times the cube root of y to the 7th, and you treat each one separately. That's probably the easiest way to do it. We're going to work backward. We're going to start here at the end, okay? So we have y to the 7/3, because the exponent goes as the numerator, index should be the denominator. The next one, the one in the middle, is going to become x to the 5/3. And then the last one is 6 to the... Now you need to think of what the exponent on the 6 is. It's not a b, it's a 6, okay? exponent is really a 1, so it's going to be 6 to the 1/3 power. Now, one way to notice that you're doing this right is that your denominator should be the same throughout, because our index on every one of those is the same. So if you get something different, you know you're doing it wrong. That's one way to check. The denominator should be the same throughout, because the index is the same throughout. Let's rewrite them all together. So it is 6 to the 1/3, x to the 5/3, y to the 7/3. And then there's our answer. Okay? A little tricky, but that's how we do that problem. We're going to move on to some more examples now, and all of these new examples just say to simplify. When you're working these out, I want you to think about our rules of exponents, okay? Because that will help you understand how to solve these problems. We're doing things we already know. We're just applying it now so that we have a rational exponent. This first one here is y to the 2/3 in parentheses raised to the 3/4 power. It's a power to a power. Think back to section 5.1 when we learned the rules of exponents. If it's a power to a power, we multiply them together. So we're going to multiply these fractions together. 2/3 times 3/4. When you multiply across. Okay, so you get 6 over 12, which reduces to 1/2. So it's y to the 1/2 power, and that's all we have to do. Now, as a general rule, when you're rewriting these, when it says simplify, if you started out with a rational exponent, your answer needs to have a rational exponent, unless it tells you to switch it. Okay? So here, since we started out with rational exponents, our answer needs to stay a rational exponent. The next one, kind of the same idea. We have s to the negative 1/6 times, in parentheses, to the negative 4/3. Power to a power, we're going to multiply our fractions. Negative 1/6 times negative 4/3. We're going to use a different idea here. You could multiply across and reduce, but we're going to cross cancel. Something that goes into both 6 and 4. Well, 2 goes into both of them. 2 goes into 6 3 times, and 2 goes into negative 4 negative 2 times. So that reduced it a little bit for us. Negative 1 times negative 2 is positive 2, and then 3 times 3 is 9. Now, if we worked it out, we would get 4 over 18, which does reduce to 2/9. You're going to get the same answer either way. All right? So now our answer is s to the 2/9. One thing to watch out for, especially on these that are power to a power, is if you get a negative exponent, because then you have to go through and rationalize that denominator. Luckily, on this example here, we had both negatives, so they canceled each other out. 2 negatives multiplied together becomes a positive, so we got rid of it. But do watch out for that, because you can't have a negative exponent. You're going to have to take it to the denominator and then rationalize it. Okay, this next one here, we have x squared to the 4/3 power. Now notice I have some extra directions here. I want you to give both the rational and radical form. So we're going to start with the rational exponent. Okay, x squared to the 4/3. Well, 2 is really 2 over 1. Okay, so we're going to do 2 over 1 times 4/3. Multiply across. 2 times 4 is 8. 1 times 3 is 3. So our rational form is x to the 8/3 power. All right? Now, our numerator is bigger than our denominator. Okay, so what happens on this particular one is that it can be reduced, and that's why we're going to take it to the radical form. Just because we can reduce it farther. We're going to rewrite it now. Okay, so it's going to be the cube root of x to the 8th. That's our radical form. And we've talked about this before. We take our exponent, and we're going to divide by our index. So we have 8 over 3, which gives us 2 remainder 2. So when we rewrite it, we have an x squared out in front. That's what the first 2 is. And then the cube root of an x squared underneath. That's what our remainder is. So there is our answer in radical form. They're both the same thing. They mean the same thing. They're just written in different forms. Okay? On these particular ones where your numerator is greater than your denominator when you work it out, when you get an answer here, I do want you to take it to that extra step. I want you to take it to radical form. Because leaving it as x to the 8 over thirds, well, that tells me what it is, but I want you to simplify it farther. And to do that, you have to switch it to the radical form. So that's one case where you're going to have to do something else, where it shouldn't be what you started with, because we started with rational exponents, but I want you to end with radical form. Okay, so that one needs to switch. Let's look at these next set. We've got, how many more? We got 6 more. All right, the next one here is a to the 2/3 times a to the 4th. Well, we talked about this a little bit earlier. Okay, you're multiplying two things that have the same base. So what do you do with the exponents? You add them. Now the catch is you have 2/3 plus 1/4. You can't add fractions unless you have a common denominator, so you have to get a common denominator for these. 3 and 4. Our common denominator is going to be, what can go into both of those? What's the least common multiple? It is going to be 12. Okay, so here we have to multiply the top and bottom by 4, and over here we have to multiply the top and bottom by 3 in order to get that least common multiple. Well, 4 times 2 is 8, and then on the bottom we have 12, plus 3 times 1 is 3, and on the bottom we have 12. And when we add fractions, the only thing that's going to change is the numerator. 8 plus 3 is 11. We get 11 over 12. So our final answer is a to the 11/12th power. Now notice we don't have to rewrite that in radical form. Okay, we started with rational exponents. We should end with rational exponents. And we can leave it that way because our numerator is smaller than our denominator. Okay, so that's good. The next one, we got to do the same type of thing. Difference is we have a negative exponent in there. Okay, we have x to the negative 3/8 times x to the 4/3. Again, we got to get a common denominator. We have negative 3 over 8 plus 4/3. We're adding them because we're multiplying two things together with the same base, so we add the exponents. We want the least common multiple between 8 and 3, and that is going to be 24. So over here, we have to multiply the top and bottom by 3, because 3 times 8 is going to give us 24. And on the other one, we have to multiply them both by 8. So the first fraction, 3 times negative 3 is negative 9 over 24, plus 4 times 8 is 32 over 24. And we're going to add them together, and again, the denominator won't change, only the numerator. We have negative 9 plus 32, which is really, you could switch it around if you need to, 32 minus 9. And 32 minus 9 is 23. Okay? So our fraction now, our rational exponent, is going to be x to the 23 over 24th power. And again, you can leave that one the way that it is because our numerator is smaller than our denominator. And we started out with rational exponents, so we should leave it as rational exponents. Okay? Here's our next example. They're kind of blended together, so I'm going to split the paper in half so you can see them. The next one here is p over p to the third. Or, sorry, the 1/3. Now, when we had a fraction like that, you should remember what we do with our exponents. We subtracted them. Okay, when we multiplied them, we added them, but when it's a fraction, when we're dividing, we're subtracting. So we really have p to the first here on top. So it's really 1 minus 1/3. We got to get a common denominator again, same thing as when we're adding. Okay, we can rewrite that 1 as 3 over 3. So now we have 3 over 3 minus 1 over 3, which is 2/3. Okay, so we've got p to the 2/3, and that is our answer. Okay, now if we would have had a negative, it would have gone to the bottom. When we subtract it as negative, it should have moved to the bottom. For this one, though, it's positive, so it stays on top, p to the 2/3. The next example here, we're going to do the same thing. We have t to the 3/4 over t to the 1/2. We have to subtract those exponents. 3/4 minus 1/2. Again, we got to get a common denominator. The least common multiple between 4 and 2 is 4. So over here, we just need to multiply the top and bottom by 2. So 3 over 4 minus 2 over 4 is 1/4. It's positive, which means the t is going to stay on top, and we get t to the 1/4. There's our answer. Another way of thinking of that is that 3/4 is bigger than 1/2. If you do things like cooking, you would know that your 3/4 measuring cup is bigger than your 1/2 measuring cup. Okay, so since the 3/4 is bigger, that variable needs to stay on top. The exponent's going to move to the top. Our next one here, we did one like this earlier. I just want to review it again because it's something that you have to know. You'll see it again. We have w to the negative 4/5. Okay, negative exponent, which means it has to move to the bottom. Okay. Now I'm going to give you a shortcut. Earlier we rationalized the denominator. We switched it to a radical form. Here we're not going to do that. We're going to multiply by a well-chosen 1, but we're going to use a rational exponent this time. We want that bottom number to be a 1. Okay? That exponent needs to be a 1. That way we would get rid of the fraction. So we need to figure out, since we're going to add these together, if we're multiplying, we add the exponents, what can we add to 4/5 in order for it to equal 1? And the answer is 1/5. Okay? Because 4/5 plus 1/5, we add across, that would really be 5/5, which reduces to 1. So now we're going to multiply these together. W to the 1/5 times 1, well, that is W to the 1/5. And then on the bottom, we just talked about that. We add the exponents together. 4/5 plus 1/5 would be 1, so it's W to the 1st. And that's it. We've rationalized the denominator. We've gotten rid of it, but we used a rational exponent this time. And that's a lot easier, okay, than going through and showing all that work for rationalizing the denominator. You could use the technique of rationalizing the denominator. Okay, you could go through and rewrite it as a radical and then rationalize it. But again, you started with a rational exponent, so you should end with a rational exponent. So this method here is probably quicker because it stays that way throughout. We don't have to switch it and then switch it back to a rational exponent. It stays a rational one throughout the problem. We have one more. We have y to the 1/2 plus 1 over y to the 1/2 minus 1. Now you've seen this before. We saw something similar to this when we talked about square roots and cube roots. And we had to use a conjugate. Okay? The reason we have to use a conjugate is we could rewrite that as the square root of y minus 1. And then we have a square root in the denominator. Okay? You can't have a root in the denominator, and since it's not the only thing in the denominator, we have to use what's called the conjugate, which we've talked about before. But we're going to leave it the way that it is. We're not going to change it to square roots. Okay? You could if you needed to, but we're not going to. To get the conjugate, remember, all you do is look at that sign in the middle. Everything stays the same but that sign. So we're going to multiply the top and bottom by y to the 1/2 plus 1. Now, this is a difficult problem. Okay, it takes a little bit of thinking through to figure out what you're going to multiply and what you do with the exponent. It's a little confusing. So stay with me, stay focused as we work through this. Okay, on the top, we're going to FOIL. You have y to the 1/2 plus 1 times y to the 1/2 plus 1. So you multiply your firsts together, and when you're multiplying them, remember you add the exponents. So you have y to the 1/2 times y to the 1/2. 1/2 plus 1/2 is 1, so it's y to the 1st. Now you multiply the outside two. Y to the 1/2 times a positive 1, that's 1y to the 1/2. Multiply the inside two. 1 times y to the 1/2, that's another positive 1y to the 1/2. And then you multiply the last two. 1 times 1 is 1. Now let's see if we can combine anything. Again, let me run through it first again real quick. First, y to the 1/2 times y to the 1/2, you add the exponents, okay, because you're multiplying. So 1/2 plus 1/2 is 1. And then you multiply the outside. Y to the 1/2 times 1 is y to the 1/2. The inside, y to the 1/2 plus 1 times positive 1 is y to the 1/2. And then the last one, 1 times 1 is positive 1. Now you can combine these two in the middle because they have the same exponent. You cannot combine it with the first one because the first one has a different exponent. So we have y plus, you have 1y to the 1/2 plus 1y to the 1/2. That's really 2y to the 1/2 power because I have two of them. It's like saying I have an apple and another apple. I have two apples, okay? Plus 1. There's our numerator. And that's the tricky part, okay? The numerator is the hard part. The denominator is not as bad because for the denominator, when we use that conjugate, they're exactly the same except for the signs in the middle. So I gave you that shortcut, and we talked about it earlier, the first last shortcut. You don't have to completely do FOIL because the inside two will cancel each other out. So we're going to multiply y to the 1/2 times y to the 1/2. We just did that on the numerator, okay? Y to the 1/2, y to the 1/2, we're multiplying, we add the exponents. 1/2 plus 1/2 is 1, so it's y to the first. And then we multiply the last two. Negative 1 times positive 1, well, that's negative 1. Can't combine anything there, so it's y minus 1. And then you are finished, okay? Do not try to cancel anything. Leave that fraction the way that it is. You just want to check and see if you can combine anything in the numerator or the denominator, all right? That's another one that is a tricky problem, okay? It requires some thinking, a lot of complex thinking about what your conjugate should be, having to add exponents, add terms together. You're putting a bunch of ideas together in the same problem. So that's what makes it tricky. Now, those are your notes for section 5.7 on rational exponents. I know it is a lot. There are a lot of examples, a lot of ideas going on there, but it's stuff that you already know. Okay, you know the rules of exponents. You just now need to apply them when the exponent is a fraction. And you do have that key idea that you can rewrite. That's really the new concept. Everything else is stuff that you've done before. We're just adding that new idea that we can take a rational exponent and rewrite it as a radical if we need to. Okay, again, those are your notes for 5.7 on rational exponents.